So in order to find the x-coordinate of the vertex, you have to do negative b divided by 2a. So in this case, negative 15 over 2 times 5, which gave you negative 15 over 10, which gave you negative 3 over 2. To write a quadratic in standard form, you'd say x equals both of those values. Then you add the 3 to the other side, so you have x plus 3. You multiply by 4 and then subtract 3. So you have 4x minus 3, so that is factored form. And then you FOIL. And then to get the exact values, I chose to do quadratic formula. You could have also completed the square. Could have also factored because they ended up being rational roots. So because those values were real rationals, you could have also factored. Questions, comments, concerns? So we are starting chapter 6. Chapter 6 is operations with polynomials. So a polynomial is essentially just a quadratic with more terms. So a quadratic is a polynomial by definition. It is just a specific type of polynomial. So the words we're going to see most often in this chapter, and it's important to understand, are the words simplify. Simplify means to rewrite the expression without parentheses, without negative exponents, and without having multiple like terms. So if you have like terms, you need to group those like terms together. You also don't want decimals. So oftentimes when we're simplifying, we're not getting decimals. A polynomial, the word poly means many. So polynomial means many terms. So again, poly means many. So polynomial is many terms. The degree of a polynomial is going to be whichever term has the highest exponent. So I believe in lesson 6.3, we learn how to classify polynomials by degree. So if the highest term is squared, we call it a quadratic. If the highest term is degree 1, it's linear. So those are the ones you've already learned this year. We're going to then learn okay, if the degree is 3, 4, 5, how do you refer to that polynomial? Again. All right, a product of powers. A product of powers says that you have two variables being multiplied together, and when you multiply two variables together, you add their powers. So a product of powers says that if you have two variables being multiplied together, we add their powers. You don't have to worry about putting an example unless you think you really need it. We're going to do examples in class today. So I'm really just looking for the definition for you to get. The examples are more visual for people that want to see them. So again, if you have two bases that are the same, so xx, 3, pb, then you add their exponents together. If you have two terms that are the same variable and you're dividing them, then you subtract the top and the bottom exponents. So the bottom gets subtracted from the top. So if you had x cubed over x squared, you'd subtract the 2 from the 3. You have a negative exponent. You cannot leave it negative in your problem. So you have to rewrite it as a positive. So again, if the exponent is negative, you drop it to the denominator as a positive. If the exponent is negative, you drop it to the denominator as a positive. If it's negative in the denominator, you move it up as a positive. This one we should all be pretty familiar with. If you have a power to a power, then you multiply. A power to a power is multiplied. If you have a power outside the parentheses, then you distribute it inside to every term. If you have a power outside, it distributes inside to every term. And that's the same if it's outside and they're being divided inside. So if they're dividing inside and it's to a power outside, the power goes to both or every term in the numerator and the denominator. And then my favorite rule, anything to the power of 0 is 1. Anything to the power of 0 is 1. Anything to the power of 0 is 1. Any number, any variable, anything. And calculate like e to the 0 a lot. So nice when it becomes a 1. Okay. So what we're going to do today is focus on simplifying those types of terms. We're going to focus on simplifying these types of terms. So a monomial expression is simplified when the following check marks are true. There are no powers to powers. There are no powers of powers. All bases appear exactly once, meaning you've combined all like terms. All fractions are in simplest form. And there are no negative exponents. There are no negative exponents. Let's go. So you have a to the negative 3 times a squared b 4 times c to the negative 1. So anything that is a like base, you are going to follow your rule for. So a to the negative 3 times a squared is really the same as saying a to the negative 3 plus 2. Because that's the rule. Like bases add their exponents. B to the fourth has no like terms, and c to the negative 1, we're going to drop to my denominator because it's negative. So it's going to become b4 over c. And again, you don't have to write the 1. Now, we do need to group these together. So negative 3 plus 2 is negative 1. So that a is now also to a negative exponent. So what we're going to do is drop it down as well. So you have b to the fourth over a c. If you have a power over a power, then you subtract. So n squared over n10 is the same as saying n to the 2 minus 10. So n squared minus 10 gives you n to the negative 8, which is 1 over n to the 8th, because you cannot have a negative exponent. Okay. And then if you have a power outside, it distributes to all terms inside. So this is 6 squared, r squared, squared over 3 squared, s cubed squared. So power outside comes in as a power to every term inside. A power to a power multiplies. So you get r4 over 9 s6. The last thing you need to do is clean up your coefficients. So 36 divides by 9. So you're going to change that to a 4, r to the 4 over s to the 6. I did do 3 squared. 3 squared.
Yeah, but what about for the exponent?
3 times 2.
So you would multiply them?
Yes. Yeah, a power to a power is multiplied. So like, you do multiply them, not square them. So like what you said was true. Oh, then you tricked me. You said,
No, I was wondering which way.
so you square the numbers, but a power, anytime you have a power inside raised to a power outside, they multiply. Okay? Is something, so that quick review, like there's no notes for you to copy down on this, but basically there are a few rules, and we already talked about them a little bit back in chapters 1 and probably 2. Polynomials cannot have division of a term that has division with a variable. I don't know why my dots all turned to use. So essentially you need to know or recall that you can't divide by a variable via polynomial. So remember when we said like, is this linear or non-linear? The rules were you couldn't divide by x. So that's part of the polynomial rules. You also can't be a polynomial and have a square root. Square roots are not polynomials. Square roots are square roots. So if it has a square root in the problem, not a polynomial. Polynomials can only be variables raised to a whole number power. So again, variables raised to a whole number power. definition so that if you looked at something, you can tell is that a polynomial or not. So if I look at this term here, it contains a square root. Can a square root be a polynomial? No, because that's a fraction power. So this is not a polynomial. And again, we're going to really investigate polynomials and not polynomials more in lesson 3 when we start to classify. Now, it says no division, but that doesn't mean you get divided by a number. Dividing by a number is not the same as dividing by a variable. So number 2 is a polynomial because all of my powers are whole numbers and I have no division by variables. So this is a polynomial. The degree comes from the sum of each term's exponents. So this first term here has a degree of 3 because its exponents add up to 3. This next term here has a degree of 14, or a degree of 7 and 2 together to get 9. So the degree of the polynomial is 9 because it's the highest degree. You don't add all the degrees together, it's just the highest degree of one term. Values for degrees don't come from the numbers. A number has a degree of 0. A number has a degree of 0. So it does not affect the degree of the polynomial. Okay, number 3 is set up to trick you in the sense that this does not look like it contains division at first glance. However, if you reorganize that to follow your rules, you end up with 3 divided by x because x has a negative exponent. Therefore, this is not a polynomial. This is actually what we call a rational because it has x in the denominator. So this is not a polynomial. The last part is, can you add and subtract like terms? Can you add and subtract like terms? So, I know I'm hearing a lot of no's, so I'm nervous. We're going to distribute our negative. So that's always the trick, right? Everybody forgets to distribute the negative to every term. So you have 2a cubed plus 5a minus 7 minus a cubed plus 3a minus 2. A cubed, a, number. So 2a's cubed minus a cubed is a cubed. 5 plus 3 is 8a minus 9. So is that a polynomial? Yes. What's its degree? 3. Because that's the highest exponent. So this is what we call a one variable polynomial of degree 3. One variable because you only have 8. Eventually we'll get into multivariables. If you have a plus sign, you can just imagine the problem without parentheses. So 4, negative 2, negative 9, negative 5, 3, negative 6. 4 minus 2, negative 9 and negative 5, 3 and negative 6. minimum. It is a quadratic. So it is a polynomial of degree 2. So our negative is between them. So you distribute divide like terms. Sometimes when I distribute, I rearrange so my like terms are next to each other. I also sometimes distribute and I write them so that they are stacked. Another quadratic, reflected, open down. So this is one where, like, again, if you wanted to stack them, that negative sort of distributes. So this is like saying minus 4x squared minus x plus 5. So then I add them in columns. Because I feel like the radicals and the exponents are the trickiest part, we're going to continue to review them tomorrow. So you don't have any homework with them tonight because I feel like it takes seeing them twice to get all of those rules. So for tonight, like that first page is like, what's the degree? Put them in standard form. And then the second page is adding and subtracting. So pretty easy. And then tomorrow, like I said, we'll do more with like powers and exponents before I give you problems with powers and exponents. Because today was like, take all the rules in, take some time to like understand, and then we'll do a bunch of problems.